All right, this video is part one of a two-part video on reviewing Learning Target 2.3, so you can do a retake. This first question shows two histograms, and we have to compare and contrast them. Luke is throwing darts at a bullseye. So a bullseye looks like this, and the goal is to try to get as close to that bullseye as you can. And we can see that with his right hand, most of the darts were around 9 inches from the bullseye. So, if this was to scale, 9 inches would be like out here. Whereas with his left hand, most of the darts were within 0 to 1.5 inches, so very, very close. So more than likely, Luke is left-handed, much more accurate throwing darts with his left hand. So this first question says, how many darts did Luke throw within 6 inches of the bullseye with each hand? So what we do is we first look at the right hand, and then we'll look at the left hand. So to look at the right hand, we can see that there's 6, so we want to see how high this bar goes. Well, there's the 2, so this must go up to 1. This is a 2, this goes up to 4, and this goes up to 5. So if we add those together, 1 plus 2 is 3, plus 4 is 7, plus 5 is 12. So Luke threw 12 darts within 6 inches. Whereas with his left hand, he threw more. If we look between 0 and 1.5 inches, it goes all the way up to 11. 1.5 to 3 inches, it goes all the way up to 10. 3 to 4.5, it goes up to 8. 4.5 to 6, it goes up to 6. So if I add all those up, 11 plus 10 is 21. 21 plus 8 is 29. 29 plus 6 is 35. 35 darts. Okay. So I want you to do the same thing, practice on this one. But on this one, Luke is throwing, and we want to know within 12 inches. So you're going to have to add these all up all the way up to 12 inches. So add those up for the right hand, add those up to 12 inches with his left hand. Down here, instead of analyzing a histogram, like up here, these are histograms, this is a normal distribution curve. So this is a bell curve. Notice that the percents on here are always the same. It's the numbers on the bottom that change. The middle number, that is always the mean. And whatever you're adding by is your standard deviation. So 66 to 69 is up by 3. So the standard deviation must be equal to 3 because we're going up by 3. So the first question is approximately what was the average mean height of the students? Well, that number, so 66 inches, which happens to be the same thing as 5 feet, 6 inches. Okay. The next question, about how many of the 1,600 students were taller than 5 feet tall? So 5 feet is 60 inches, so you look at your diagram, there's 60 right there. So we have to take all of these percentages and add them together. So add all those together. So 13.5 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. If you add all that up, it equals 97.5%. So if I want to find 97.5% of 1,600, so 97.5% of 1,600, I have to divide this by 100, which is 0.975. Of means times 1,600. And you see what that equals. So again, just to confirm, so if I do 97.5 divided by 100, I can see 0.975. So then I do 0.975 times 1,600, and that will tell me my amount. So 1,560 students. So I want you to do the same thing for part C. except here I want to see how many students were above 6 feet tall. So not 5 feet, but 6 feet. So 6 feet is at 72 inches. So you're only using these two percentages. So it's going to be a lot smaller number because there's not a lot of area under the curve there.